Good day to you, my dear friends. It's time to solve some LeetCode problems. But before that, mm, let me open this page with my profile. Well, the reason I wasn't able to stream normally in the last couple of days is that my mother is visiting and I'm trying to entertain her and to show her all the different locations and so on and so forth. There was a lot of traveling. Now I sent her on a guided tour so I can solve LeetCode problems the usual way, without any haste, without hurry, without worry. Paradise. But I still tried to solve a LeetCode problem every day and to make a stream, as you know. And one day I had to get up at 5 in the morning, at 5 a.m. to be able to stream for you. And you know what? LeetCode still gave me an empty day, a day without submissions. Bloody LeetCode. You know why? I guess I know why. Because I have a +6 time zone and it was just 5 in the morning. So LeetCode considered it being yesterday, I think, well, the day before, because you see submissions are recorded in the UTC time zone. So my streak is broken. We are back at the square one, well, square two, because yesterday was the first day of the new streak. And it's going to be hard to beat this number. No, this number. It was such a beautiful picture, you know. It's a shame, really. But let's continue. And let's start with the problem from yesterday. What was it? Number of students doing homework at a given time. And let me find my solution from yesterday. Oh no. What's the difference? Okay, let's take it. Well, as you probably remember, we have two arrays, start time and end time, and we have an integer, query time. And we want to count students that are, doing their homework at this time. So we iterate through start time and we check if our query time is bigger or equal to start time and lesser or equal to the end time. And we count. Is there a better way? Well, first of all, there is a simple way. Do you hear that? It's a hurricane again. Jesus. You have a between method. It's a lot better. And of course we can, make a one-liner out of this. Let's test. And of course, we can replace start with _1 because it's a shortcut for this first parameter. And we can replace index with _2, and then we do not need this part. Let's check. But is this the best way? Let's go to the section of solutions. Look at this one. It turned out that we can count with a block. And then we do not need, well, actually let's leave it for now and comment it out just for comparison. So, start time and each with index, and now we do count. And inside of this block we can just use this line, I believe. Yes. So it's a one-liner. But what troubles me beyond any measure is that I cannot understand which way is more efficient, because here we also use this each with index method and we count our results inside of the block that we send into each with index method. Here we also have this each with index method, but it doesn't do anything except for returning the enumerator. And after that we do count. So do we iterate twice? First to create this enumerator and then to count depending on this condition? Probably yes, we do this twice. But what happens here? Do we also iterate twice? First to create this enumerator and then to run this block? Or just once? That's a part that I do not understand yet. And there is another solution, by the way, using zip method. Let's also try this zip. Without a count, just to see what will return. Look at this array of arrays. And then we just check if our query time is between first element of subarray and second element of subarray. Well, not first and second, but 0 and first, you know. 0 element and 1 element. How do we call it? forget about it, you understood me. And of course, after that, you want to count. And here we definitely go to each of the original arrays to create this new one, and then we iterate through this new one and through its sub-arrays. It's interesting because I didn't even know about zip method, but it doesn't look very efficient. But it's a one-liner, you know. So if you do know which one is better, let me know in the comments. Me personally, I prefer this one. Such a dilemma. But let's solve some other problem. Well, not solve. First of all, let's discuss some problem from, that I solved previously before I started streaming. Oh yes, let's discuss concatenation of array again, because yesterday I told you a very stupid thing. Okay, so this was my final solution, like this. And I told you that there is not much difference in the way we solve these problems. We can do like nums plus nums or nums times 2 or nums concat nums. But actually, now I think there is a difference, because when we do nums equals nums times 2, let's return nums. Of course, it stayed the same, because nums times 2 returns a new array that we put here. Now let's try concat. And also return nums. You see, we changed the original array of nums, and it may seem that it doesn't matter much because we put whatever we do here inside this new variable n's, but these are arrays in Ruby, and they work the same way in JavaScript and in PHP and everywhere. Let me explain. Well, let me open Paint, of course, because there is no better way to explain things. Okay, here is it. Let's say we have nums array or variable, and in this variable we store not an array itself but a pointer, pointer to some place in memory where we store all this array data. And when we do something like ans equals nums, then ans also gets this pointer and point to the same location in the memory. Great. And that's, wait a second. Let me open everything back. That's what happens here, because ans point to the same place in memory where nums point, because we use concat method. But when we return a new array here, nums and ans point to different locations, so they waste like double as much memory or something like this. And it's not good. What I mean is, I still didn't have enough sleep to explain all this. Nums points to one location, ans to another, see, in these two variables we have pointers that point to the same place, and here we have pointers that point to different places, and that's a problem. So there is a difference how to solve this problem, although it's a very easy problem, you know. Still, the best way is to do some method that is going to return the original modified version of original array and not something new like this. Oh, it's very hot in here. And now we can go and try some other problem. Yes, build array from permutation. It's a short and simple problem. We have an array of nums, and when we iterate through this array, we want to create a new array ans first of all. And the first element of this array is going to be, well, we take a value of the first element in our original array, and it's 0. So we take 0th element from this array, and it's also 0. We put it here. Then we have a 2. So we are going to take the second element, element 2, from nums, and it's 1, and we put 1 here. And then the first element, and it's 2. And we put 2 here, and so on. So this is a solution. And do you remember how previously we used map with a bank? And here it won't work at all, of course. Because when we arrive here, we will replace this 2 with 1. And then when we arrive here, we will want to take this 2. But there will be a 1 there. And we'll get 0, 1, 1, 4, 4, 4, and so on. So of course we can't solve solve it with the bank. I didn't have enough sleep, so it's hard for me to talk, I'm sorry, but I want to solve something today. And I believe this is the best approach, although there are some solutions. Let's see. It's about the same. Yes, we can use some kind of an iterator. But map is the shortest one, the nicest one. And now, finally, let's solve something new. What do we have here? Article views 1. Oh, it's an SQL problem. Let's see. Okay, no primary key. It may have duplicate rows. Each row of this table indicates that some viewer viewed an article. Here is it: article, author, viewer, and view date. Find all the authors that viewed at least one of their own articles. Oof. Okay. Well, for now, let's select author ID from views, where it's not gonna work, right? Let's see. Can we do distinct, or it won't help us? No, it's good. 7 and 4. Here, 4 and 7. Let's do this as ID, group by ID. Something like this. I don't remember how it's done. Group by sending. Oh no, probably we just need order by, right? Of course. So Let's use distinct here and order by ID. And it's green. Submit. And probably there is a better way to solve this problem, but I'll tell everything about it tomorrow when I will have some time to investigate this problem and to find the best approach. I'm kind of tired, but I promised you that we will attempt a medium problem. And I have a medium problem that I started like a week ago. This one got into some problems. For now, let's remove everything. So what do we want to do? We want to replace the value of every node to the sum of all nodes to the right plus its own value. So all these nodes make 26, and we add 4 and we get 30. Here we have 8, and then the value of previous node is 7, so it will become 15. And how do we solve it? Well, first of all, we are going to return root, because in the end we want to return this whole tree, you see. So we definitely return root. And if actually for a few nights I wasn't able to sleep because I was thinking too much about this problem, and I think I have a solution, but I didn't check yet. I just solved it in my head. Where is the chat? Sorry, here is it. Empty, of course. If root right. Actually, let's just make a guard clause. Return if no root. Node is going to be root right. And if it's not nil, let's do else first. Also, we are going to need another parameter. Let's call it tail as we usually do, and by default it's going to be 0. What is tail? Well, you'll understand everything in a minute. let's just use plus equals, of course. So what is a tail? Well, imagine that we go to the right from this first node and we changed all these values and we came back here and we make this node 30 and then we go left. No, and here we again want to go right to this node and it's 3 and somehow we wanted to add 30 to this node, so we are going to carry this as a tail, and by default it equals 0, so when we reach here to the 8 we just add 0. See? By the way, let's check this. Yes, it's all wrong, but why is it wrong? Well, because we do not use this value anymore. Well, not anymore yet. Mm-hmm. As a tail we are going to send what exactly? This root value. Mm-hmm. Let's check. Yes, it's 26, 21, and it's not 30. Of course it's not 30, because we return node here, and the value of this node is 21, but we actually want 26. So how we send 26 all the way back here? That was the question that ruined me the first time I attempted this problem. But now I have an idea. We do not need to pass anything. Look. I guess we have to check if root right and root right value minus our root value is more than 1. Then we just going to update root value, but how many times? Let's use a for loop, huh? All of a sudden I don't even remember how it is used. For I in, and we are going to use range here from root val plus 1, 3 dots, not inclusive, root right val plus equals I. Oof. Let's check. Great. So to the right, everything is working. To the left, nothing is working. But why? Oh. 21, 26, 15. Yes, all good. Left, root value. Gets here, we have a root right. We skip this because of this condition. Go here, BST. Of course, we are going to use going to use tail. Please work. Flawless victory. Let's submit and ruin everything. Of course. God damn it. Let's use this test case. So, oh wait, what's the difference? Is the same? No. I see. Okay, let's use this test case. 6, 7, 9, and we do not have 8 at all, and that's why we can't solve this. We're probably going to solve this one, but oh no. Yeah. Of course it's going to fail again. That's a miracle, you know? Actually is a miracle. I think I can write a test that would ruin everything here. I mean, let's go back to this problem, to this test case number 3. Well, actually it's not number 3, I don't remember how it is called. So we skipped 8. See, there is no 8, it's immediately 9. But what if it was 10? And here we have something like 9. Or even better, if it's going to be 20, and here we have just like 15, 17. You see? There are not enough test cases. But we solved the medium problem. Yay! Now I have to invent a better solution for this part. Well, we can return just value and not a node. Then it could be easier, a lot easier, but we want to return root in the end, not value. We can do this in 2 methods, of course, but I want to solve everything in one. Okay, you'll have to think more about it tomorrow. And I think that's it for today, because I'm really tired and we solved a lot and we raised a lot of interesting questions. So I'll see you tomorrow. Thank you for being here. And yeah, that's it. Bye.